All right, welcome back. This is Mr. Sanchez with West Covina. We're conducting Unit 1, Meeting 1 for EL 140 Residential. My objectives for the day: select proper wiring methods for several types of residences, explain the purpose of a GFCI, AFCI, explain the importance of the manufacturer installation specifications for whether it's a AFCI, GFCI combination breaker or it's an AFCI, GFCI receptacle. The other thing we want to know is the GFCI, AFCI receptacle. What is the difference between some of our standard receptacles? How do they receive the protection downstream to your other standard receptacles that are not AFCI, GFCI? We want to give them all these simple details because for us, it's more of a common sense thing that when we look at it. But when we look at our students' perspective, a lot of them are very clueless to all the details that we are very well accustomed to. So breaking it down point by point, detail by detail, let's start with the drawing. I start every lab assignment with some type of drawing or explanation. I want them to be able to read a manufacturer's drawing schematic. I want them to have an understanding. If they can draw it, they can build it. If they can see the wiring method, there should be no issue when it comes to application. So I always make it a point to point out to them for every class, because obviously we're always receiving newer students than the more experienced ones as we continue on through core. Explaining the turns, straight turns, grounding conductor, bare copper, green, grounded neutral, white. Obviously, I utilize blue on the board because of the whiteboard concept. And then we have the ungrounded conductors, which could be black and red typically. Nowadays, with the code requirements, we have AFCI, GFCI circuit breaker requirements. So for the most part, new construction, we want to explain to them that that's how they're going to be dealing with an AFCI, GFCI circuit. It's going to be starting at the circuit breaker itself, and how those circuit breakers are either pigtail, I'm going to say generation 1 AFCI combination breakers, or have a pigtail for the white neutral. The second generation of those AFCI, GFCI combos have a plug-on neutral. Obviously, we have to have a panel that accompanies the plug-on neutral concept. But I illustrate to them the circuit breaker symbol and the fact that the neutral and the ungrounded will have specified locations at that particular breaker. In an older home, or let's say old work, where those residences are not required to have had AFCI, GFCI breakers, nor are they required to upgrade to them. So a lot of those homes, a lot of those residences still want some GFCI, AFCI protection. Why? Because it's great for people. It has eliminated and really turned down the rate of electrocutions in homes. So explaining to them how it works and how it saves lives, how it monitors the outflow of current, and how it monitors as it comes back, as the tripping mechanism will monitor the circuit. That's an explanation we want to cover with them. I like to explain the fact that here's a 15 amp GFCI illustrated here, where you have the vertical ports visible, compared to this 20 amp standard receptacle that has not only the vertical, but the horizontal port, to illustrate that it's a 20 amp rated receptacle. So I explained to them the difference. Obviously, I'm not gonna have a circuit that starts at 15 amps, a 15 amp circuit breaker, a 15 amp GFCI, and then put in a 20 amp. I understand that, but I make that point to them that they gotta be able to see the difference, and that we don't mix the amperage ratings of devices. If we start a circuit breaker with a 20 amp, then we have 20 amp devices. If we start a circuit breaker with a 15 amp, then we have 15 amp devices. So they get that explanation thoroughly. They also get the explanation of the wiring schematic. So I try to make it as simple as possible, showing the conductor colors, illustrating them here on the side, telling them what the little arrow tip means about the home run, to make the ease of drawing and the illustration of the lines make it to be more seamless, or where it's not so confusing and too much to understand. So we got our home ground neutral, we got our home run grounding circuit coming in here, we got our ungrounded conductor. Another thing I point out to them is about wire management in this illustration. I got a box here outlining. I got my raised grounding nipple at the bottom corner. Why? Because I know that my incoming conductors are coming from this direction. So when it comes in, the first thing I have them do is tie down that bare copper, lock it in, use a green wire nut, terminate on the device, and then continue on with that connection to that originating grounding conductor and continuing on to the last device where here it's terminated. Starting back here again, we got the grounded neutral. Obviously just with the arrow tip, it's coming in on the line side of a GFCI. This is where we start bringing in the illustration of the manufacturer requiring that line side incoming power comes into the bottom, and as it's illustrated in the back of these devices. And then we leave out with that neutral through the load side and continue on to the second or downstream receptacles. We also have the ungrounded conductor coming in from the home run, coming in on the line side, exiting out through our load side, continuing on to the downstream receptacles. But one of the things that I point out to them is that incoming conductor comes in, I'm gonna utilize that knockout primarily. Why? Because it's closest to my grounding raised nipple. It's coming from this direction. And I wanna have a seamless and a good wiring plan management system in my box. So I wanna exit directly across and continue on downstream. So you should always have one entry, one exit. That way, as an instructor, we're managing not having boxes that are all knocked out. And therefore, it kind of looks trashy after a certain point when we have a box that's all knocked out and a student is looking like, well, this is being used. So I try to limit it to 1 and 2 knockouts all the time. And they utilize that box and they say, oh, it looks pretty good. It's in good shape. So it's about perceptions too, fellas. As we come in, we follow that same format downstream. I know that my incoming power is coming from the left. I'm gonna have my grounding nipple closest again to that entry of the left side here for that knockout. And obviously we're terminating in this section. Again, I got my neutral coming in. And I tell them, just like a standard receptacle, it doesn't have illustrated by the manufacturer line and load, but I want them to practice that same concept repeatedly. Come into the bottom of a receptacle with your incoming power as if it was defined as line. Come in with your grounded neutral as if defined as if it was line, right? And if they had to continue on, then they could use the top side as defined as load. And obviously the grounding system is attaching to the box, attaching to the device, and our circuit is complete. One of the other things that we want to point out is here on the plan. So that one of the back points that I want to mention is make sure that we take advantage of the fact that, one, what does the NEC require for these circuits? What does it require for the materials? What does it require as far as applying a load for this type of device, for a receptacle? How much volt amperes is required for each receptacle in the circuit based on whether we're starting with a 20 amp circuit or a 15 amp circuit. We want to make sure that we have the understanding that this is a regular standard receptacle, that we're going to have a multiple of 3 in the circuit, but like I said, we're going to determine, like I gave my class a little calculation based on the NEC's recommendation of applying 180 volt amps to each receptacle in the circuit. And I give them a size of a room, and they can determine how many are going to be able to apply and fit in that room within that parameter of that calculation using Watt's law. So in this illustration, I'm just giving you the first and the second so that you can see how it would continue on and so forth. So just keep that in mind, that always incorporate the NEC in the materials. What does the NEC say about my materials I'm using today? What does NEC say about the requirements of AFCI, GFCI? And like in California, again, we want to make sure that we're following all the standard codes like California Electric Code, Title 24, and seeing if there's any more restrictive codes that we are aware of, whether it be an AHJ jurisdiction that we worked in and so forth. We want to bring those points. The other thing we want to illustrate is the required tools. Here on the lab sheet, we got a hammer that's applied here in the tool list. Well, most guys will probably say, what is this for? Well, if you're going to be utilizing side nail boxes, whether it's a single gang or a double gang, we're going to need that hammer. We might need it to tap out a knockout or something if somebody doesn't have the strength to knock it out by hand. We got our standard wire stripper. We have our standard multi-tool stripper. Obviously, I guess most guys are going to prefer this. Why? Because I don't have to be switching back and forth if I have to do some type of crimping or shortening down a screw and so forth. One of the things I see here on the list, it's called channel lock pliers. I always illustrate to my students the proper names. So this is a tongue and groove plier. This is some people call it a pump plier. Channel lock, I illustrate to them that that's a name brand. It's one of the first brands that came out with the tool, so everybody honors the name of the tool with that first brand that brought it out. We got our diagonal pliers, and I explained to them the nuances of why is it shaped that way? How do we cut wire? All the little small details and our experience with these various tools that are listed here, we want to go over those things. You got to remember that some of the students that you're incoming on core, maybe they didn't have the benefit of having you, a detailed instructor, during intro phase. So you always got to make sure and kind of evaluate where are they at with the small details that they should have got in intro. We don't want to leave them farther behind if they are a step behind other students who may understand what's going on with these tools and how to utilize them. So we want to evaluate new students as they're coming into our core, making sure that they're up to par with all the small details we would have given them an intro. We want to explain the importance of torpedo, of a level, period. Whether it's a horizontal leveling or a vertical plumb type of look at whatever we're installing, whether it's a panel, whether it's the box itself, all those utilizations are important. We obviously have a list, a tool checkout list. One of the things that I make sure that I do on my tool checkout list is I count the tools in front of the student. I make sure that they have the necessary tools for the job, but also per the tool checkout list that we've developed. The other thing that I'll do is I'll have them count it back right in front of me after I've counted it. I make mistakes, and I'll admit it. I missed a tool, and then they see it. That's why we do a two-man count. They get it, they return it back, I count it, they count it, and then I sign. We have a multimeter. One of the things that I like to use the multimeter is as much as I can on every project, but let me illustrate it here first, real quick, because this is usually where I do it and give it to everybody, generalized instruction. How can I use the multimeter before I apply power to my circuit to verify that it's going to work, to verify that there's not going to be a short circuit, to verify that there's not going to be a ground fault. So we got it set on continuity, and I'll come over and I'll start right here at the incoming home runs. First, I'm going to check my grounding, and I'm going to check every box, every device, and hear and listen for that tone. If I got a tone there, I check my grounding is intact. The next thing I want to do is keep my probe on that grounding and touch the ungrounded conductor. No tone, that's what I expect. Touch my neutral. No tone, that's what I expect. And so forth. Making sure that there's no inadvertent short circuits or ground faults downstream. So that's a simple illustration that I can see without applying power, especially to somebody who's inexperienced or they're showing you signs that they're not doing the best practices. You want to give them the illustration of going to the next level of safety, utilizing their tools and understanding how to utilize them to the best of their benefit. As we come into the unit over here, we can see that we started, it's been set up for an AFCI, GFCI combo breaker. It's got a circuit that's starting at the panel with that protection, coming down to a standard receptacle where that protection will be provided for the whole circuit that is attached from there forward downstream. So this is a good point to illustrate to them the code section that applies to this. So one of the things that I emphasize in almost all my classes, don't just go ahead and give them the code number. Don't just go ahead and start throwing out codes and say, this is where you find this is where you find that. Take them through the index. Take them through the travels of finding the code sections on their own first. I give everybody the chance and the opportunity. I show them how to look for things in the NEC, and then I assign it to them. Before they begin work, I want each of them to search out the codes, and I'll pick out a couple in my mind that I think are the most important, and I'll have them search it out, and that way they can have the time to try to go through the obstacles that the NEC provides to us. And then once they discover it or they don't discover it, then we bring it to the table, okay? So we want to illustrate to them, how do we check our circuit? We want to make sure that our circuit is, one, we're set for the proper voltage, whether it's AC or DC. What do we have here at the panel? And before I even energize, I want to make sure I give that visual check. I want to make sure things look appropriately connected. I want to give my critiques before we even go to that point. If I see anything that looks dangerous, like maybe for example, I seen this with a lot of students recently, when they cut this outer jacket, they've seen these videos online where they take the utility knife and they swipe this way on the front, swipe this way in the back, and rip off. Well, I always tell them, that endangers, the sharpness of that utility knife endangers a cut to our insulation on our inner conductors. And that's where we're gonna have that short circuit, that ground fault. So look for those little small defects and before you energize, because there's nothing more embarrassing as an instructor that you didn't catch the ground fault or the short circuit that's obviously visible by a bare conductor being cut. Okay, so one of the things I'm going to illustrate is, okay, as we energize the circuit, what should we have? Our PPE, right? So before I get that far, let me get those gloves on. And another thing, we provide them these gloves, but I always illustrate the fact to my students, do not trust these gloves electrically, because if you're using them, and I don't care if we're moving material around, picking up trash, as soon as you get a puncture on one of these gloves, they're no longer electrically gonna save you or protect you. And there's also a fabric back end. Utilize, if you want to be protected, utilize the leather gloves. They're more durable. They're going to withstand punctures or scrapes. So one of the things I utilize is utilize a refresher. I'll tell them, okay, when I'm going to do a voltage check, this is where I start. I have a standard procedure. I'm going to come up and check line to line, and I might get 208. In this building, that's the potential, 208. Then I'm going to tell them, give me a line to ground check. I'm going to come over here to the ground, give a ground to line 1 check, give them the voltage 120, and then a ground to line 2 check, and I got 120. And then I'll tell them, okay, give me a ungrounded, a line to grounded neutral. Shift over again. Got my grounded neutral bus, and I got it to line 1, 120. Line 2, 120. And I show them the nuances of what is the standard procedures for checking. I also want to make sure that they check once they energize their circuit, do I got 120 coming out of the circuit breaker? Is it faulty? Is it correct? Okay. Once I know that is flowing, I'm going to bring this down over here, and I'm going to make sure that they check the voltage at each of the ports. Do I got 120 there? Do I got 120 here? I don't want them getting the habit of going here on the side, because if they're utilizing a metal box and they're not careful, they're playing that game of operation, and then they ground fault and mess up the probes, they get an arc, all those things. When it comes to lockout tagout, we got to explain the importance, take the advantage of explaining the importance each time that we open up these disconnects. Explain and make sure that they know what the disconnect is and how to check the power of the disconnect if we have any troubleshooting issues. I illustrate to them, keep the door closed, keep your distance, energize. Did we get a light bulb? If we didn't get a light bulb, the light bulb could be out. That's now another troubleshooting effect. Or the circuit breaker is de-energized. So obviously I'm explaining the obvious to you guys here in this lab. But as a new instructor that may be watching this video, I want to give you as much content so that you can see that there's a lot more to it than just a GFCI circuit. There is so much that we can add in and give a full lab, more than just the concept of 1, 2, 3 GFCI setup. That's simple and easy for all of us. We could do it in probably 15 minutes, right? But that's not the point. We got to take it from start to finish and troubleshooting effect. Okay, guys, we'll see you in lab. Thank you for your attention.